Hi everyone, welcome to Wood Physical and Mechanical Properties course. I'm your instructor, Dr. Nur Sakinah binti Muhammad Tamad. Module 5, Strange Properties of Wood. What do you understand about strange properties of wood? Orthotropic nature of wood. Wood is an orthotropic material. It has unique and independent mechanical properties in the three directions, which are longitudinal, radial, and tangential. The longitudinal axis is parallel to the fiber or grain. The radial axis is normal to the groove rings or perpendicular to the grain in the radial direction. And the tangential axis is perpendicular to the grain but tangent to the groove rings. Mechanical properties most commonly measured and represented as strange properties. Wood as orthotropic materials, hence the strength of each dimension will be different. Generally, there are two classifications to representing the strength of different dimensions. First, parallel with grain. Second, perpendicular with grain. Strength properties include bending strength. Bending strength is the ability to absorb shock with some permanent deformation and more or less injury to a specimen. It is a measure of the combined strength and toughness of wood under bending stress. Stiffness and elasticity. Resistance of wood to change its natural size and deformation. The wood that difficult to bend is stiff and easily bent is flexible. Compressive strength. Compressive strength is the maximum stress sustained by a compression specimen having a ratio of length at least dimension of less than 11. Shear strength. Shear strength is the ability to resist internal slipping of one part upon another along the grain. Values presented are average strength in radial and tangential shear planes. Impact bending. Impact bending is a hammer of given weight is dropped upon beam from successively increased height until rupture occurs of beam deflects 152 mm or more. Tensile strength is the resistance of wood to force acting across the grain that tend to split a member. Hardness is the resistance to indentation using a modified Janka hardness test by the load required to embed a 11.28 mm ball to 1/2 of its diameter. Toughness is the resistance of wood to split. Natural factors that affect wood mechanical properties. The natural factors that affect wood mechanical properties are: note, specific gravity, reaction wood, juvenile wood, and pitch pocket. Specific gravity. Specific gravity is an excellent index of the amount of wood substance contained in a piece of wood. It is a good index of mechanical properties as long as the wood is clear, straight grained, and free from defects. However, specific gravity values also reflect the presence of gums, resins, and extractive, which contribute little to mechanical properties. Note: a knot is that portion of a branch that has become incorporated in the bole of a tree. The influence of a knot on the mechanical properties of a wood member is due to the interruption of continuity and change in the direction of wood fibers associated with the knot. The influence of knots depend on their size, location, shape, and soundness, attendant local slope of grain, and type of stress to which the wood member is subjected. Reaction wood. Abnormal woody tissue is frequently associated with leaning bole and crookling of both conifer and hardwood. In softwood, the abnormal tissue is called compression wood. It is common to all softwood species and is found on the lower side of the limb or inclined bole. In hardwood, the abnormal tissue is known as tension wood. It is located on the upper side of the inclined member. Many of the anatomical, chemical, physical, and mechanical properties of reaction wood differ distinctly from those of normal wood. Juvenile wood. Juvenile wood is the wood produced near the pith of the tree. For softwood, it is usually defined as the material 5 to 20 rings from the pith depending on species. Juvenile wood has considerably different physical and anatomical properties than matured wood. Juvenile wood has a high fibril angle, which causes longitudinal shrinkage that may be more than 10 times that of matured wood. Pitch pockets. A pitch pocket is a well-defined opening that contains free resin. The pocket extends parallel to the annual ring. It is almost flat on the pith side and curved on the bark side. The effect of pitch pocket on strength depends upon their number, size, and location in the piece. A large number of pitch pockets indicates a lack of bond between annual growth layers, and a piece which pitch pocket should be inspected for shake or separation along the grain. I think that's all in the module 5. Thank you for your listening.